Hey there, kids. Welcome to another math video. This is for Eureka Math Grade 5, Module 2, Lesson 10, homework. And so now that you are professional multipliers, you are going to learn about multiplying with decimals. And so we're taking some of what we've done in the previous few lessons and we're putting it all together, multiplying with the standard algorithm, multiplying using an area model, also estimating. And the estimating is kind of important because we're talking about where to place the decimal, and you really kind of have to know where it is, because if you're off by even one place value position, your number is going to be all out of whack. So I have used in previous videos this method before where I rename it in unit form and not standard form, and I said, hey, try it this way, it's going to come up later. Well, here's the later. Here we are multiplying with decimals and using the standard algorithm while taking the decimal out and putting the word in, so that we can then have kind of an easier time of what to do with the decimal. So we actually just ignore it for the most part. So at the bottom, the objective: multiply decimal fractions with tenths. So really just easy little tenths, one decimal place to the right. By multi-digit whole numbers, that means the other factor is going to have a couple of digits, maybe 2 or 3. Using place value understanding to record partial products. And that's where the area model comes in. So it's all connecting now. So let's get to it. We've got to estimate for each one, use an area model, use the standard algorithm. Remember to express your products in standard form. That's really part 4. So you have to do 4 things for each of these for the beginning. Let's get going. So first of all, we're going to estimate, and this is where, some of the answers will say, oh, answers may vary, but really in all likelihood, you could say 53 times 1. Some kids will say 50 times 1. So something around 53 or 50. And the point being, not 537 or not 500 or not 5. So the place value number of places is what we're really after. So take your 53, and for this one, let's do, and we want to have our three ones. So let's do this, and we're going to talk about our area model using our decimal values on top. So I have tenths, so I'm going to be labeling it with tenths. So I have 1, but it's 10 tenths, and 2 tenths. Okay, so it's 12 tenths. So I've got 10 plus 2 tenths. Don't let this confuse you there. Okay, so 10 plus 2 equals our tenths. And so if I have the tenths, why is this going to come in? Well, it's going to try to match our first partial product. So if I have 3 times 10, 30, and then 3 times 2, 6. So let's go to here in the standard algorithm. 3 times 2, 6, and 3 times 1, we've got 3. So when you add them together, I should have 36. But again, we're having tenths times ones. You can write that here, because anything times ones will give you the other value. So let's work this one out. If I have 50 times 10, I've got 5 times 1 for 5, and the 2 zeros. And then I've got 5 times 2 for 10, but don't forget the 0. And remember, these you're kind of adding as we go across here. And so at the bottom, or for our second partial product, done here, so move over just like you would in a regular problem. 5 times 2 being 10, carry the 1. 5 times 1 is 5 plus 1 is 6. So we've got our second partial product there. And add these. So we have 636, but what? So tenths times ones is tenths. So we've got our estimated answer around 50. I've got the area model so I can see these partial products. I have my standard algorithm with 636 tenths. So now my last thing is to put the product in standard form, which, remember, you're using that renamed total here, the 636, with the tenths, you have to put the decimal in so that there's no word, but we're finishing in that position. So that's what's happening today. Lots of things so that you can show place value understanding. Let's try it again. Take this first thing and say, all right, well, it's roughly 2, roughly 80, roughly, I should get around 160, or a 3-digit answer if you prefer that. So take all your tenths, and we're going to put these on the top. Notice that I had the decimal value that was second, and I put it on the top. And here we have the decimal value first, and I'm still going to put it on the top. Thinking of all the tenths that I have 21 tenths. And so when I put it onto my area model, it's going to be 20 plus 1 tenths. It's 21 tenths. And 82. Remember to stack them up with the larger on the bottom, larger place value positions on the bottom, smaller on the top, because we're starting with our 2 in the ones place. So then set up your area model. 20 times 2 is 40, and then 2 times 1 is 2. When you add those two together, I expect to get 42 for my first partial product. 2 times 8, 16, 2 zeros. 80 times 1 is 80. When I add these two together, I expect to get 1680 for my second partial product. Let's go over here to our standard algorithm. It's tenths times ones again. So 2 times 1 is 2. 2 times 2 is 4. So 42. And then done with the first position, so move over. So I have 8 times 1 and 8 times 2. And double check your partial products, and we're in good shape. Add. And now I have what? What word? Tenths times ones is tenths. Now write your answer in standard form. So when you renamed it, when you call it unit form, you're taking the decimal out. So this all here is the same as this here in standard form. So if you write the word, you don't need the decimal. If you put the decimal, you don't need the word, because that would be redundant. It would be saying tenths. Okay? So let's move on down here where we no longer use the area model, but we are still going to estimate. Then use the standard algorithm. Don't forget to write your answer in standard form. So we're tying in the unit form here so that you'll see, hey, guess what? I can eventually just write everything using the decimal, but forget about the decimal while you multiply, and then just stick it in at the end and you'll know where it goes. So again, estimate first. This is roughly about a 4 times 30 for about 120. Oh, and then also comparing your answer with the proper number of place value positions. That's something you should do. Instead of 1,722, that would be way too big. You got to get back here to 172, which is a lot closer to 160. So compare the number of place value positions. All right, standard algorithm. 4 times 2. 8, 4 times 4, 16. Lining up very carefully. I'm done with the first digit. Go to the second. 3 times 2, 6. 3 times 4, 12. Add 8, 12, 2, 3, 4, and 1. But it's tenths. So 1,428 tenths. So now I'm going to write in standard form, taking this and showing 0.8. This has to be in the tenths place. That's where my number ends. Next one. Also compare. 120, 142, close enough. It's all about place value positions. Okay, and then if I round this up 58 tenths to say 6, and I could have 60, I could use a 360. Could you go to 70? Sure. Times 6 and have 420. The whole idea, answers may vary, is that this is probably going to round to about 6, and then some people will leave it at have 60 or 70. Some even might leave it at 65, but then you have a regrouping, and that's always a hassle. So the idea is to make it easier for yourself. All right, standard algorithm. 5 times 8 is 40. 25, 29. Next one, row 2. Done with the 5, move to the 6. In this second, what I always say, the tens place, because this is really 65. So it's 6 tens. 6 tens times 58 tenths. So 6 times 8 is 48. Use that for 6 times 5, 30 plus 4, 34. Add 17, 4, 5, 6, 7. So 3770 tenths times ones, which is what we were doing all up there and here too, equals tenths. Show that in standard form. When you have 377.0, you really just are interested in the 377. That's your final answer for standard form. Okay, and again, you should always be working these out before you watch the video. The video is really just homework support, not copying. You should pause it, do the problem, and then check afterwards to see how you did. Okay, for the next one, roughly 3. You could do 16. If you get it too far and it's not really that big of a number, like if you say went up to 20, that's kind of a big change. You could do 15 if you're more familiar with your 15s. You could leave it at 16 even. So you have options here, and answers may vary on this for what you prefer to do. I might say, hey, I know my 15's a little bit better, so I want to be close to 45. But you can certainly even use 20 if you choose to round it up like that. Now this one they don't have set up for you with the standard algorithm, but you can do it yourself. So you're going to do 33 tenths. Label it with word forms, because remember, we're only having one place value position to the right. That means this is in the tenths place, so our label is tenths, times 16. And we're doing the actual multiplication, not the rounded, so don't multiply by what you rounded. 6 times 3 is 18. Then 18 and 1 is 19. Done with the 6, hold this spot with a 0 and move over. 1 times 3, 3. 1 times 3, 3. Add your partial products. 9, 10, 11, 12, 3, 4, 5 tenths. So 528 tenths is equal to 52.8, which makes sense that it's a lot closer to 45. Okay? Give yourself a little bit of room. And let's do another one. Okay, so 15.6 times 17. Let's just round 17 to 20. And we'll keep 15 at the whole number. Just drop that right off. Because I know 15 times 2 is 30. But there's also a 0. So take your 156, because this has more digits, and label it with your tenths word times 17. We know we're going to have 2 rows of partial products, so start here. 7 times 6, 42. Then we have 35 plus 4 is 39. Then 7, 8, 9, 10. Next row, done with the 7, so move over. This place, 1 times 6, 1 times 5, 1 times 1. Add your partial products. 2, 9 and 6, 15, carry the 1, 6, 1 and 1 is 2. So our final answer, remember, in word or unit form, 2,652 tenths, which is equal to 265.2. And that makes sense that it has 3 whole number digits. 300 is close to 265, but it's too far away from 2,652. So that's how you know the decimal goes there. Let's do another one. If I use 73 times 2, I could, but it'd be so much easier to just use a single digit. So 70 times 2, 140. Remember, we just want to get close. It doesn't have to be exact. We're not even, we're even greater than 50 apart. That's okay. It's just about place value. For this one, you can put either one on the top. It does not matter. I'm going to put 73 on the top. Usually I've been starting with the tenths on the top. This time I'm going to put it on the bottom to show you it doesn't matter. Okay, 4 times 3, 12. 4 times 7, 28, plus 1, 29. Done with this. Hold that 0. 2 times 3, 6. 2 times 7, 14. Add them up. Comes down 2, 9 and 6, 15. 4, 5, 6, 7, and 1. Tenths. Which means 175.2, standard form answer. Yep, it's 3 digits. Yes, it's 3 digits. Why do I keep saying that? Because that 0.2 hardly matters. We keep dropping off these little decimal fractions because they're so small. And so we're really just trying to round it or get it to the place where it's pretty close. 140 is pretty close to 175. It's a lot closer than 1,752. Okay, for this last one, you can bump this all the way up to, say, 200. You could bump this down to 50 or 60, or bump it up to 60. It doesn't matter. We're just trying to get close to the basic place value. 2 times 6 being 12, and then 1, 2, 3 zeros. So our expected answer is a lot bigger than what we've had before. But that's okay. I mean, it should be. We've got 4 digits in our first number. I almost put a decimal. Whew, habits, habits. Tenths. 57. Okay, 7 times 5, 35. Then 21, 22, 23, 24. Then 63, 64, 65. And then 7 and 6. 13. Okay, so first partial product, 1, 3, 5, 4, 5. Double check that you have that all the way across. Next row, starting with the 0 because we're done with the 7, multiplying with the 5. And if you have your carried over numbers, you can write right over them or on top of them. 5 times 5, 25. Carry the 2. 5 and 3, 15. 16, 17. Carry the 1. 5 times 9, 45. 46. And then 5 times 1 is 5 plus 4 is 9. And again, when you have lots of digits, it's always good to double check. 9, 6, 7, 5, 0, making sure that they're all in order in the right columns, place value positions. Everything matters. 5, 9, 7 and 5, 12. Carry the 1. 6, 7, 8, 9, 10. 9, 10, 11. So we have lots of digits, but we should... let's see, if I put a comma here, it's 110,295 tenths. But what does that look like in standard form? Because I'm just going every 3 places to put the comma in so I can read it properly. But when you label it tenths, it's going to look a little bit different. 11029.5, which means our actual comma is here. So this only helps you read the tenths. This is our place value position. The 9 is in the ones place. Okay, so this is your standard form answer that you need. Okay, again, pause the video, do this on your own, and then check it. Oh, and click subscribe and come back. I hope these are helpful, but try to do this work on your own, especially on the homework pages. Okay, Mr. Jansen is building an ice rink in his backyard. What? That will clearly not in California. That will measure 8 4/10 meters by 22 meters. What is the area of the rink? Area, they're always throwing this in there. Area is the length times the width. Memorize this formula. If the measurements are here, we just have to multiply. You can do these in any order. 8.4 on the top, 22 on the top. Let's do 84 tenths and 22 as our other factor. Multiplying with 2 should be nice and easy because it repeats. 2 times 4 is 8. 2 times 8 is 16. Hold this 0 here. Move over. Then you're 8. Then you're 16. Always row 2 shifts over 1. Add 8 and 6, 14. 6, 7, 8, and 1. 1848 tenths, which is 184.8 area meters squared. The area of the rink is 184.8. All right, last one. Rachel runs 3 2/10 miles each weekday and 1 5/10 miles each day of the weekend. Rachel should take a break or she's going to get shin splints. How many miles will she have run in 6 weeks? My goodness. Well, how many weekdays are there? And how many weekend days are there in 1 week? So you can make a tape diagram if you want to. It's not really necessary here because you can do the 32 tenths for all the weekdays, and then we can do the 15 tenths for the days of the weekend, and then you can put these together to make a week. So multiplying 10 and then 15, 16, that's tenths, plus 10, 2 times 1, there go the lights a little bit out. So 2 times 5 is 10, carry the 1, 2 times 1 is 2 plus 1 is 3, that's tenths. So what do these numbers look like in standard form? Well, it looks like 16 plus 3. So that is 19. So that would be 19 miles per week. I'm sorry. Yeah. And then we still have to multiply by the 6 weeks. Miles per week times the 6 weeks. Okay, and this is all just a whole number. These were tenths, but now it's whole numbers. So multiply 9 times 6, 54. And 6 times 1, 6 plus 5 is 11. Miles in 6 weeks. There you go. So I hope this has been helpful, and I hope to see you on another video. Have a great day. Bye for now.